Hello friends, myself Vikas Shakya. I welcome you all on my channel WSADATA Learning Platform. And from today onwards in this series of socket programming, I will start about the socket server programs, how to write a program which will act like a server in C++. Okay, so let's start. I have opened the IDE, right? So before you start writing your program in Windows, you need to understand two things. Like first thing is you need to include this Windows winsock.h file, and then apart from this, you need to add this library WSOCK32. Just go to the linker and press input, and then you can see this library. I have added this library WSOCK32.lib, right? This is the library which contains the definition for all those functions which have been defined in winsock.h. I hope you understand what is the concept of libraries, because I'm not going to discuss about the libraries. For that, I may create some separate playlist on my channel. But today, I'm not going to discuss about the libraries and how they work and how you use them in program, right? So you just need to remember that you need to include winsock.h, and apart from this, you need to add that wsock32.lib reference in your library section, in your linker section, right? So if you are writing a server program, then what all you need to do is you first need to initialize the socket, which will be listening for the client request. And then you need to initialize the environment for SockAddress structure. What is SockAddress? I will let you know, and how to fill that I will let you know. And then you need to bind to the local port. Why you need to bind to the local port? My system on which my program is running, there are a number of services running on my system, but all those services has the same address. My computer has an address over the network, and all those services have the same address. If some client is coming to my computer and he needs a service from certain program or from certain service, right, then that the particular client need to know that at which port I need to go through so that I reach to the correct program. So ports are exposed for that purpose. Okay, so we need to connect to the local port. So you can take any port apart from 0 to 256, because those are reserved ports, and on those ports you have certain programs already running, which are the system programs. So system services are there, they are running. So greater than 256, you can take any port. So usually we take the port as 9000 or 6000, 7000 in that area, right, in that limit. Okay, so then after binding to the local port, you need to listen to the request from the client, because some client may need to connect to you, or some client which is already connected, he may need to send some message to you, right? So for that purpose, we need to listen to the request from the client, and then you need to keep waiting for the new request and proceed as per the request. This is the listen, where you are listening for the new client, and then you need to process those requests for which you are listening to. Okay, so that thing should be in a loop. Your listen will be standing there. When you call the listen, there is a system called listen. Then that system call will enable your program basically to wait for the new connections from the client. Okay, and then after that, you need to create a while loop, infinite while loop, where you are processing the request infinitely, and then when it's done, you need to come out of that for loop, while loop or for loop, whatever you use, right? So for that, you need to do a proper signal handling as well. Signal handling I can cover in this. I will try to cover in this the signal handling as well, so that both the things about socket and signal handling, how to gracefully exit your application, your server, how you can do that I will try to cover. Okay, so let's start with this one, how to initialize your socket. You need to call a function which is called socket. So today I will try to cover few things like socket system call, and how you can initialize the socket address structure, and how you can bind to your local port, and how you can listen, right? And in next video I will do this thing, keep waiting for new request and proceed as per the request, right? So this thing I will cover next, but today I will try to cover all these four. Okay, so socket is a system call. The first argument is the address family AFINet. I will let you know what does this mean, and then it asks you for the type. So the type is we are using is sock stream, which is a stream socket. I mean the connection oriented socket. We have discussed about the connection oriented and connectionless sockets in the previous video. So in this video, we will use that, how to use that. So we are going to use the sock stream socket, right? And the next argument is the protocol, which protocol you're using. If I provide 0, then it will use the underlying protocol. I mean, if your system underlying framework is using the HTTP protocol, then it will become HTTP. But if you want to use the TCP protocol, you are free to use that. You can use IP proto TCP. This is the one. So you can use this one. So if you see this AF INET, let's discuss them one by one. Socket stream, you know, this also you know, just need to discuss this one, AF INET. So if I press F12, then you can see that in the header file provided by the Microsoft as well, you can see that when you are connecting over a network where you will use TCP or UDP, then in that case you need to use this address family, right? So that your system can properly resolve the addresses. Your program should be able to resolve the addresses. For that, you need to provide the correct address family, right? So here, since we are using the stream socket, connection oriented socket, and we will be using the TCP, transmission control protocol. So in this case, I'm using AF INET, right? So let's see if it is working fine or not. So before that, I need to put if and socket smaller than 0, then what will happen? I need to print a message. The socket not opened. So in case you are not open a socket, your socket call fails, then it will return -1. And if it returns -1, then this message should print it. Otherwise, this message should get printed. Open successfully. Okay, so let's see what happens with this one. So let's run this. Okay, so if I run this, then it shows me the socket not open, right? So it means this has returned -1. This socket system call has returned -1. Well, where did we do the mistake? Where we have done the mistake, right? So the mistake is that when you're writing a program, a socket program in Windows, then you first need to initialize the WSA variables, right? What are WSA variables? Basically, these are used. Basically, this is a set of functions, not a set of functions. Basically, it's a environment supporting the socket programming on Windows environment, right? So it enables those APIs which will enable basically socket programming on your Windows platform, right? So how you can initialize that? You need to create WSAData, the variable of WSAData, WS, and then you need to initialize this. If WSAStartup, and then you need to use make word. This is a macro where you need to specify the major and minor versions of WSA families of functions. So for that you provide 2 and 2. These are the valid versions, the latest versions, and then I provide address of WS, right? So these are the 2 arguments. If this fails, then it will also return 0, less than 0. So what will happen in that case? You can just write this piece of code there. Okay. So here you can write WSA failed to initialize. Otherwise, you can write like WSA initialized. Okay, so let's see what happens and up to what point it goes. So just start the local debugger, and then you can see WS initialized and the socket opened successfully, right? So this you need to do. So you can see that WSA was initialized and also the socket was opened successfully, because if this function call is successful, then only all the socket calls, all the socket APIs will start working, right? So we have successfully opened the socket. If you want to print the socket ID, what is the socket descriptor ID, then you can just print it here and socket, and let's see what happens, what it prints. You can see that there will be a number. You will be able to see a number there against the socket descriptor. Okay, so you can see 184. This is the number. This is the socket ID. Okay, so this call is done, this call is done, and the next one is initialize the environment for sock address structure, right? So what we do in the sock address, basically there is a variable called, there is a structure rather, struct sockaddr in SRV. Okay, so this sockaddr in structure contains the details about the family, the port where you will be listening, and the address, your your machine address, IP address. And this is a special array which you just need to initialize with the 0. This has nothing to do with all the things, but this you need to initialize so that it has some space to store some information which it uses during your program executes. It contains that kind of information, right? So you need to just initialize it with the 0. So let's start and let's write that one. So we have declared a variable with name srv, and first of all we need to provide srv.syn family is equal to af underscore inet, and then we need to write like srv.syn underscore port is equal to h to ns. Let me first define a port. Has define port is 9909, right? So here I will write h2 ns port, right? So you know what is this? H2NS, host to network short, right? So we need to specify the network byte order when we are providing the port. We have studied about the network byte order in the previous video. And then we need to write like srv.syn address.s underscore addr is equal to inaddr any. Right? So if you write like inaddr any, then it means that you are assigning the address of your local machine. Because I'm creating my own machine as the server, then what I'm doing, I'm just trying to make my own address, make my own port address, and sorry, not port address, the machine address, the IP address of my machine to this s underscore addr. Right, so this macro will simply collect my IP address, my system IP address. I don't need to provide it like 127.0.0.1, right? I don't need to do that. Okay, so if I need to do that, suppose you have to do that, then in this case you need to write inet underscore addr, and then you need to provide 127.0.0.1. Right, this is also a way to do this, and this is also a way to do this. Srv.syn addr.s underscore addr is equal to inaddr any. So both these things will work. Why we have provided inet underscore addr? What it will do? It will simply convert this string to byte order. I can directly assign it to here. I mean, I can directly write like strcpy and then I can assign this value. But what it does, it simply gives a long value. Basically, it needs a long value which is compatible to my IP address, which has been provided in a IP address manner. right? And that too in network byte order. So for that purpose, we will use initadr. If you don't want to use initadr, and if you want to create your own system as the server, then you simply use initadr any. So in that case, whatever address your system has as of now, that will be taken to this s_addr. And then we have this mem set. I told you, like the last element, srv dot sin0, and then you need to write like what value will provide 0, and the size is 8. The size of this srv is 8. So here you need to give address of srv.sin0. Right, so this is the way you can provide it, and now it should have been initialized. Right, when we will compile it, then we will see that how it works. And after that, you need to bind it. So first of all, let's see if this compiles or not. So just compile it, build the solution. Okay, so it has compiled. So let's see if bind call can work or not. So next step is to bind to the local address. So to bind to the local port, let's declare one more variable on top of this function, int nret is equal to succeess. Let's put it simply 0 as of now. Okay, so here what I will do, nret is equal to bind, and then just what it needs the socket name. It's nsocket, it needs socket ID, so it's nsocket, and then it needs the address, sockaddr address, right? So you can just write like sockaddr asterisk, and then you can write like address of srv, because it takes srv. Sockaddr in can be typecasted to sockaddr. This is srv, and then it needs the name lane, right? So it will take the lane, so size of sockaddr, and this should complete here, right? So this is the way you need to pass the values to it. Now again, if nret is smaller than 0, then endl fail to bind to local port, right? So this is the simple message which will be printed, and else what will be printed? Cout endl successfully bind to local port. Okay, so this is the way it should behave. If it fails, then we should simply exit. In fact, anywhere you have written the failure code, failure condition check, then you need to provide this. It should be like exit underscore failure. Okay, successfully bind to local port. It should come if our program is working fine. So let's see what happens. Okay, so we are successfully able to bind to the local port. Okay, so till now our program is fine. We are just ready to listen to the new requests. Okay, so what we will do here, nret is equal to listen listen, and then you need to provide here nsocket, the socket name which you need to listen to, and then backlog. I put it 5. What is backlog? The second argument is the backlog, which tells you like how many requests at a time your server can pool, right? How many requests can be there in the active queue for your server. So 5 can be there. If more than 5 clients come, then in that case, those rest of the clients apart from 5 clients, they need to wait in the wait queue. that queue is maintained internally, right? So if you are in a active queue, then in active queue maximum 5 requests could be there, right? So let's see if it works or not. So if nret is smaller than 0, then if it is smaller than 0, then we can just copy paste it, and then we can do one more copy paste here. Failed to start listen to local port. And if it works, then started listening to local port. So it has started listening to local port. Let's see what happens if my function call is successful. If it is able to start listening to the new clients, then in that case we will be able to see this message. Otherwise it will show me this message. So let's see what it shows. I think I need to restart it. There is some problem. Okay, now you can see that it has started listening to the local port. It has successfully bound to the local port, and it has started listening to the local port. So now if new connection comes, any new client comes, then my socket, which is the N socket, which is the listener socket, that will be able to accept the new connections over the network, right? So how that will be done, and how my server can receive the new connections, and how it can work with the client request, that we will see in the next video, right? So it will take around 2 to 3 videos to completely write a full-fledged program having both client and servers and both connecting to each other. Okay, so first of all, the program which I am writing here, this program is written for multi-servers, multi-client servers. It can handle multiple clients, right? And then I will just write a program just for a demo that will take only a single class to let you know that how you can create a program which can work as a server which can only serve a particular client, only a single client, not to number of clients, right? So that's it for today. And in next session, in next video, what I will cover this part. Keep waiting for new requests and proceed as per the request. So till then, just see this video and then try it yourself. And please like, subscribe, and share my videos. And if you think there is something else I need to cover, then you can simply write it to the comments, and then let me know your opinion that how I can make it better for you. Okay, so till we meet next time, till that time, let's get apart, and we'll meet soon. So bye bye and have a nice day.